In this video, I will show you how to find the inverse of logarithmic and exponential functions. Now, finding the inverse of any function requires two steps. Step 1 is to switch x and y. And step 2 is to solve for y. Now, when you're dealing with exponential functions and logarithmic functions, you will probably have to change the form at some point. Whoops. Meaning, if you start off in logarithmic form, you will probably end up in exponential form. And if you start off in exponential form, like number 11, you'll probably end up in logarithmic form. So at some point along the way, you're going to wind up changing forms. Anyway, let's see what happens. So the first step is to switch x and y, which literally just means put x where the y was and vice versa. So we will have x equals log base 4 of y to the third power. So now we need to solve for y, get y by itself. The first thing you should do is we can get the 3 off of here using the power rule. The power rule says if you have the log of something with an exponent, you can put the exponent in the front. So this will become x equals 3 times log base 4 of y. Now we can use our algebra 1 skills and divide both sides by 3. Okay, that way these 3's will cancel each other out. So now we have x over 3 is equal to log base 4 of y. So once you get it down to a simple log, it's time to change the form to go any further. So if I change this to exponent form, focus on the base. The base is 4. So I'm going to start off with that 4. Now the other two expressions are going to change sides of the equation. So the y is going to go over to the left. So I'm going to have y over there. The x over 3 is going to come over to the right, but it will become the exponent like this. And that's the end. Y is equal to 4 to the x over 3 power. That's the final answer. So number 8. Again, we need to switch x and y and then solve for y. So first we will switch x and y. So we will have log base 6 of y minus 2. So we need to, now we're going to solve for y. Let's start with our algebra 1 steps. For example, we need to add 2 to both sides. So that's going to give me x plus 2 is equal to log base 6 of y. That's as far as we can go with our algebra 1 skills. It's time to change the form to exponent form. Start with the base, which is 6, bring that down. Everything else has to change sides. So the y is going to come over here to the left. The x plus 2 is going to come over here to the right as the exponent. And that's actually the final answer. Y equals 6 to the x plus 2 power. That's the inverse. Again, to find the inverse, we will switch x and y and then solve for y. So this will become x equals log base 3 of y minus 3. So we switched x and y. Now we need to solve for y. So let's add 3 to both sides. That will give us x plus 3 is equal to log base 3 of y. Now it's time to change the form. So start with the base. Now everything else is going to switch sides. So the y is going to come over here to the left, and the x plus 3 is going to go to the right and become the exponent. So this is the final answer. So number 10, to find the inverse, we will switch x and y and then solve for y. So if we switch x and y, we have x equals 4 times the log base 4 of y. Now we need to solve for y. Let's start by dividing both sides by 4. That way these 4's will cancel each other out. So that gives us x over 4 is equal to log base 4 of y. So now it's time to change the form. So focus on the base. Start with that, 4. Everything else has to change sides. So the y is going to come over here to the left. The x over 4 is going to come to the right, but it's going to be the exponent. Okay, and that's it. That's the final answer. Y equals 4 to the x over 4 power. Okay, now we're switching gears a little bit. The first 4 problems were starting out in logarithmic form, and then we had to switch to exponent form at some point. The last 4 problems will start out in exponent form, and we will have to switch to logarithmic form at some point. But still, the first step is to switch x and y. So we will start off with x is equal to 2 to the y power minus 5. Next we would add 5 to both sides, because now we're solving for y. So that will give us x plus 5 is equal to 2 to the y power. So to get y by itself, we need to change the form to log form. So focus on the base. We will start with that. So log base 2. Everything else will switch sides. So the y will come over here. The x plus 5 will come over here and go inside the logarithm. So we really must use parentheses to show that the entire x plus 5 is the argument of the logarithm. It's inside the logarithm. Alright, so that's the final answer. Y equals log base 2 of x plus 5. Alright, again we will switch x and y and then solve for y. So first we get x equals 5 to the y power over 4. So I switched x and y. Now I need to solve for y. So the first thing you want to do is multiply both sides by 4. That way these 4's will cancel each other out. So that's going to give me 4x is equal to 5 to the y power. So the last thing to do is to change the form. We need to change this to log form. The base is 5. Always start with the base. So we'll write log base 5, and everything else has to change sides. So the y is going to go over to the left, and the 4x will come over to the right. And go ahead and put in parentheses if it's more than one thing. But that's the final answer. Y equals log base 5 of 4x. Alright, 2 more problems. To find the inverse, we switch x and y, and then we solve for y. So if we switch x and y, we will have x is equal to negative 3 to the y power over 3. So now we need to solve for y. I would multiply both sides by 3 first. Okay. that will eliminate the 3. Alright, in fact, I think it would be more efficient if I did something slightly different than that. Let me start over, my friends. See this negative sign in the front? I want you to understand something about a negative sign and a fraction. Say if I have negative a over b. That is the same thing as negative a over positive b, which is the same thing as a over negative b. So in other words, if you have a negative sign and a fraction, you can have it in the middle, or move it to the top, or move it to the bottom. It doesn't matter. You can put the negative sign wherever you want in the fraction. You can't have two of them. You can't say, oh, this will be the same as negative a over negative b, because that would be positive a over b. So, of course, you knew not to do that. Anyway, I'm mentioning that because I want to put the negative on the bottom, because I think that will just make it easier to see. It'll make it more efficient. Alright, I can take care of the negative sign and the 3 in one shot now, because instead of multiplying both sides by 3, now I can see that what I really need to do is multiply both sides of the equation by negative 3. Alright, that way the negative 3's will cancel each other out. That's why I did that. So now I have negative 3x is equal to 3 to the y power. Time to rewrite this in log form. Focus on the base. The base is 3. So I will write log base 3, and then everything else will change sides. The y will come over here to the left, and the negative 3x will come over here to the right and go inside the logarithm. If you have more than one thing, you need to put it in parentheses to show that it's all inside the logarithm. It's in there. So that's your final answer. Let's do one more. Alright, most of these problems have been really simple. I think this one is also simple. Well, you know what? I see the 4x in the numerator. 4 to the x power in the numerator and the denominator. That could be interesting. So I'm intrigued. Let's see what happens. So there are two main steps to finding the inverse of something. And those steps are switch x and y and then solve for y. So let's do that. Let's switch x and y. So we will have x is equal to 5 times 4 to the y power plus 1 over another 4 to the y power. Okay, so now I need to solve for y. First, I'm going to deal with the fact that this is a fraction. I don't like that. So I am going to multiply both sides of the equation by 4 to the y power. So I will multiply by 4 to the y power on the right, and I will multiply by 4 to the y power on the left. But over here, these will cancel each other out. So that is going to give me, and you know what, maybe I'll just put the x in the front for now. I don't think it matters, but I'm going to write x. I'll just keep the way it is. So I have 4 to the y power times x is equal to 5 times 4 to the y power plus 1. Whenever you have your variable, we're trying to solve for y, and I see that my variable is in two different places. So whenever that happens, I want to get all of my terms that have my variable on one side of the equation. So I am going to subtract all of this from both sides. Basically I'm going to move this over, but I'm going to subtract to do that. So that's going to give me 4 to the y power times x minus and I think I'll just switch these around. So I'll have minus 4 to the y power times 5. I subtracted them, and I just went ahead and switched the order so that it would look the same. And all that equals 1, because that's what's left over there. So now I have this. So the beauty of it is, once you have all of your terms that have your variable together on one side of the equation, you can factor out the greatest common factor. So I have 4 to the y power and another 4 to the y power. So what I can do is I can factor this out. So I will bring my 4 to the y power outside of parentheses, and then that will leave behind x minus 5. And that equals 1. Okay, so this is much more interesting than like every other problem on this paper. So we're trying to get y by itself, so I need to get rid of the x minus 5, and I somehow need to get rid of the 4. Let's start with the x minus 5, because the way you get rid of that is by dividing both sides by x minus 5. Alright, that way these x minus 5s will cancel each other out. So that will give me 4 to the y power is equal to 1 over x minus 5. So that's as far as we can go. Now I have 4 to the y power by itself. It's time to change the form to logarithmic form. Focus on the base. The base is 4. Alright, the base is always the thing with the exponent. So I will write log base 4. Everything else has to switch sides. So the 1 over x minus 5 has to come to the left and go inside the logarithm, so I need parentheses around it. Actually, because it was a fraction, I guess I technically didn't need the parentheses. The division sign is its own grouping symbol, but can't hurt. Anyway, the y comes over to the right hand side, and the y is by itself. So this is really the answer. Just because of OCD, on all the other problems I've written y equals, y equals, y equals. So something makes me want to just flip this around so I can say y equals log base 4. And just to prove that I meant business a minute ago, this time I won't write the parentheses. So 1 over x minus 5. Again, technically, when it's a fraction, I don't need parentheses because the fraction bar makes it clear that the x minus 5 is a package deal. So this is the final answer. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.